Hello everyone, welcome back to another video. So today we will discuss uh, editorial for weekly contest 386, and I was able to solve first three problems. So we will discuss solutions of first three problems only. So first question, we are given an array A of even length and we have to split the array into two parts such that each of the array has n by 2 length and both the arrays should contain distinct elements. For example, 1, 1, 2, 2, 3, 4 can be separated as 1, 2, 3, 1, 2, 4. Similarly, in second case is 1, 1, 1, 1, but we cannot separate this because one there is no way to separate them such that both contains distinct elements. So this is just one condition we have to check. If the frequency of an element here is greater than equal to 3, that means if there are three elements, three an element is occurring three times, we cannot separate them in two arrays because one has to repeat in at least one element has to repeat in one of the arrays. So we just have to check that condition, and for that we can use just this map. And if the frequency of element gets bigger than greater than or equal to 3, we just return false, and if such condition is not met anywhere, we can just return true. So this was first question, pretty simple. So this is second question. Now second question was it took me two wrong submissions to solve this question. And so what we are given n rectangles, and each rectangle is represented by bottom left coordinate and top right coordinate, and we have to find the maximum area of a square that can be fit inside intersection of two any two given rectangles. So for example, here we are given this bottom left array, 2D array. So each index represents 2 points, which is coordinate of that bottom left point of that rectangle. For example, 1 1 is bottom left of this uh, pink rectangle, and 3 3 is the top right of the same rectangle. Similarly, 2 2 is bottom left of blue rectangle, 4 4 is bottom top right of 4 blue rectangle. Similarly, 3 1 is bottom left, and 6 6 is top right of this green rectangle. Now we have to find the intersection. We have to first find intersection of any two rectangles and fit a square in it, and we have to print the largest area of such square. So in this orange and blue rectangle, we can fit a square of side 1. So area of such square becomes 1 into 1, which is 1. Similarly, here in the figure we can see that we can fit a square between 2 2 and 3 3, and if such no we cannot fit any square, we will just return 0. So let's try to find some observations. So square can fit like this. Two rectangles can intersect like this. So they can intersect either uh, diagonal diagonally, or they can intersect like this, where one of the sides is both rectangles intersect at one of the sides. So this can be extended for all four directions. So this triangle intersected with this triangle. Similarly, this triangle intersected with this triangle. So what is common in all these triangles is the common length. For example, this is the length of first triangle. Let's call it I, and this is the length of jth triangle. And similarly, this total breadth is uh, this is total this side is breadth of ith rectangle, whereas breadth this side is breadth of second rectangle. Now we have to find intersection of these both sides, and similarly intersection of these both sides. So using those intersections we can calculate the common rectangle, which is this. Now in common rectangle, what is the largest square which you can fit? It is equal to a square of side minimum of length and breadth. So this type of square can be fitted where L and B length is L and breadth is also L. So this is considering L is less than B breadth. So first we have to find the common intersection triangle, and in that we can find square by just taking minimum of length and breadth of it. So for finding rectangle we have to find intersection of uh, both uh, sides on x-axis and both sides parallel to y-axis. So and the here n is 10 raised to power 3, so we can run two loops n square and it find I and j, and for each I and j first we will check condition I must not equal to j and calculate these sides. Now these sides can be calculated easily. So this x coordinate is equal to uh, let's take another more simpler version. So this is, let's say, x comma y, and this is x dash comma y dash. Now xy is bottom left corner and x dash y dash is top right corner of rectangle. We are given both of these. Now we have to find this coordinate and also this coordinate. So we can just check this length. Common side, we have to eventually find common side. Now this if you see can be is equal to x dash comma y, and this is equal to x comma y dash. Now this is common side which is ranging from x to x dash, and this is another common side which is ranging from y to y dash. Now this we found a range here and also range here. Similarly we will calculate for jth rectangle. This is ith rectangle, let's say, and this is j. We calculate these two ranges again, then we will take intersection of these range with respective with the range which we get here parallel to x-axis. Let's say call it as x2 comma x2 dash, and similarly y2 comma y2 dash. Now we will calculate intersection of x comma x dash to x2 comma x2 dash, and we will get a length of the intersection of those rectangles. Similarly y comma y dash y2 comma y2 dash, we will get breadth of that rectangle, and using both of these you can find the square which fits intersection of both the rectangles. So how to calculate intersection? So intersection is pretty simple formula. So if let's say I am going from A to B and C to D, So I have to take intersection of both of these ranges. So the intersection here becomes C to B. So C is calculated as max of starting range of starting point of both ranges, which is here A comma C, and last point of intersection is calculated as minimum of last point of both the ranges C comma D. And also there might be a case where both of them don't intersect. So for example A C B D. So here what we have to do is we will get answer as B to C, but we can clearly see B is greater than C over here. So for such case we can just return 0, and that means there is no such intersection found. So let's just see first intersection formula. So I'm calculating A dot first and B dot first max as we discussed here, and minimum as A dot second comma B dot second. Now I just want the length of each side, so I'm just returning length over here, not complete intersection. So if D2 is less than D, that means uh, uh, so this case, so max of A comma B, here I get B, and D2 is so the right point is less than left point, which basically this condition where there are no intersection, I will just return 0, and else I will just return D2 minus D1, which is just the length of that intersection. And this is just brute force. For int I equal to 0 I less than n, for int I equal to 0 j less than, I will check both of them are not same triangle, and I will just make pairs of all sides and take intersection of D3, which is both the sides parallel to x-axis, and D2 and D4, which is both the sides parallel to one of the axis, and I will take minimum of both of the intersections, because if we have a, let's say, a triangle of length 3 comma 4 of dimension 3 into 4, we can fit a square of dimension 3 into 3 only. So we can fit a square of minimum of both the sides. So I will take minimum and just make answer equal to max of answer comma the area of that square. In this question we have to also check for integer overflow, so use long because 10 to the power 7 into 10 to the power 7, which will go to up to 10 to the power 14, so it will give over integer will overflow, so we have to use long. Now the third question. So third question, what's very less people solved, only 877 accepted solutions. So in this question we are given an two arrays. First one is nums and second one is change indices, and we have to all of the indices in nums are unmarked, and we have to mark all the indices in nums such that in each second we can perform only one operation. So for let change indices as length m, let's say uh, in each second for each indices in change indices we can perform one of the operations. So one is to decrement any of the nums of I by 1, and other operation is to make mark any of mark change indices of s if the corresponding index in nums is equal to 0. So let's just run the first case, and we have to basically return at what earliest second the answer, the we can mark all the elements in nums, all the indices in nums, and we have to return that time after, or we can say the index before which we can perform all these operations of change indices vector. So here we are given nums as 2 comma 2 comma 0 and change indices as this. Now we can perform this. We have to at least take 8 seconds. We cannot do any other we cannot mark all the indices before 8 seconds. So let's just hand run this solution. So first we will choose index 1 and decrement the nums of 1 by 1. So nums now becomes 1 2 0. In second 2 we will choose again the same index, make it 0 to 0. Then choose index 2 at second 3, decrement it. Then again choose index 2 and decrement it. So now our nums becomes 0 comma 0 comma 0. Now we can mark that index at second 5. Then change indices of 5 is equal to 3, and nums of 3 as it is 0, we can mark it. So nums of 3 index 3 is marked now. Similarly in second 6 we can mark change indices of 6 is 2 and nums of 2 is 0, so we can mark it again. Now in second 7 change indices of 7 is 2. Now 2 is already marked, so we can just skip this second and do nothing at this point. And in second 8 change indices of 8 is equal to 1. So and nums of 1 is 0 and it is unmarked, so we can mark it. Now all the indices are marked, so within 8 seconds we can perform all the operations and mark all the indices of nums. So answer here is 8, and we cannot do before 8 seconds. So you can hand run or try to find any other solution. Before 8 it is impossible. Similarly in second case we can do it in 6 seconds, and this is the hand running of that solution. And in last case, if we cannot do it until m, that is max seconds we can take here, it is 3. So answer here is just -1. We couldn't do it because first we will just decrement this one, so nums becomes 0 comma 0. Then with 2 we can mark second index, but again there is 2, so we cannot do anything. Now the first index remains unmarked, so here answer is -1. And the constraints here are less, so the size of both the vectors is less than equal to 2000. So it is a hint that we have to use 2 for loops to find a solution. So let's just try to make some basic so try to make some basic observations. So from this constraint we can see we can use 2 for loops. This is how I break down the solution. Now if let's say first for loop is for uh, is to check if I can do, first for loop is to iterate over seconds, so for 1 to m. So if can I do it in 1 second, can I do it in 2 seconds, can I do it in m seconds. So this first for loop will take care of seconds, and second for loop will take care of to check if the value which I'm getting from first for loop is satisfying our condition, and marking all the indices, mark all indices of first of nums vector, which is of size 1 to n. So we found so this is basic breakdown. So first for loop is to iterate over seconds from 1 to n, and second for loop is to iterate over nums and check within this I seconds. So first for loop, let's say we are iterating from 1 to m and I is the current value. So within I within first I indices. So within first I elements of change indices, can we mark all the elements from mark all the indices in nums vector? So if we can, the minimum answer is I itself, because we are moving from left to right. Whatever first answer we found at I, we can just make it, so that is our answer of the whole problem. And if we don't find any I between 1 to m, we can just return minus m at last, minus 1 at last. So now if I can perform if in k seconds, let's say I can mark all the indices in nums. What does this k seconds what is the optimal strategy to, let's say we have to mark all in indices in nums in k seconds only. So first condition is that from, if let's say nums size of nums is n, so all the elements from 1 to n should at least occur at least occur once at least occur once in first in k seconds. K seconds means first k elements of uh, change indices vector. So this is first condition. Now we also need to decrement all the values of nums which are not equal to 0 to 0. So we have to somehow find a way of decrementing such that for each nums of I where it is positive, there must be some possible arrangement that after some before k seconds they also become 0 and also get marked. Now third and most important observation here is the last occurrence of this 1 to n elements will always mark that element. So we have to mark all the elements, right? So optimal strategy for marking them is to choose the last occurrence of each element and reserve them to mark the indices. For example, let's take n equal to 3 and first k uh, k elements of change indices are something like this: 1 2 3 2 1. Now let's k here is 7. Now we can reserve this 3 to mark index 3. Similarly, we can reserve this 1 to mark index 1, and this 2 we have to reserve to mark index 2. So last occurrence of all elements from 1 to n should be reserved to mark that element. Now for marking this element 2, this should make uh, nums this elements before it should be enough to make nums of 2 equal to 0. So for each of these indices I can decrement one element from nums. Now how total number of total I can at most decrement an element by 3. Now if nums of 2 here is less than equal to 3, then only I can make nums of 2 equal to 0. before the last occurrence of 2. So if it is less than equal to 3, I will just use that sum, and let's say here nums of 2 was previously 2, so I will use 2 of from 3, and I can make this remaining equal to 1 now, and these two can be marked here. Then I will go to this one and this one. Again, I don't have to mark these ones because I have already reserved one for marking, so I can use again this for decrementation. So here again I can decrement here, I can decrement here. So now sum becomes again 3. Total sum was 5, but we use this 2 for making nums of 2 equal to 0. Now again we have sum equal to 3, and we have to mark first element. Now again nums of 1 must be equal to less than equal to 3. Now if it is not equal, we cannot do anything here. So k doesn't satisfy our condition. If it is less than 3, we have to again make a remaining minus equal to nums of 1 and move ahead. Now for 3 again, we have to check if remaining is greater than equal to nums of 3. So this is the third observation which we have to make, that it is always optimal to reserve last occurrence of each element from 1 to n to mark them, and before it try to satisfy the sum required to make that elements equal to 0. So these are the three important observations. So let's just see the code to understand it better. So first I just make vector names easier because the vector names here were too big. So I just made both the names of vector as a and b, and int n is a dot size. Now I will iterate from 1 to m, so 0 to m basically. So 0 to b dot size, and what I'm doing is uh, first I'm marking all the last occurrences of elements. So if visited of p of j is equal to 0, that means I have not visited it. I will just make it equal to 1, and cnt of uh, that position, that is I have reserved that position for marking in for marking that index, and I will just make d plus plus. So this d is basically to check if I found all at least one occurrence of each element from 1 to n. Now so here what I did was, let's just take the same example, 1 2 3 2 1 1, and here was 8. So from right side I'm iterating. So first I found 3. Now I haven't visited 3 anytime. So this is, let's say, cnt. So cnt is of size I plus 1, means same as k, but visited is of size n plus 1. So we just need elements are visited are from 1 to n. So I declared visited from 1 to n, but cnt I declared from 1 to k. So first I have visited 3, I have not visited 3, so I will mark this as 1. So I have reserved this position. Then I will come to 1, again I have not visited 1, so I will mark this position. Now I have come to 1, but I have already visited 1 previously, so this will remain 0. Again similarly this will remain 1. So 2 is not visited, this will become 1. This this 3, this 2, this 1 will remain the same, 0 0 0, and d will also increment at this position. So d here incremented by 3, so value of d is 3 now. So Using D, I'm just checking if I have at least got one occurrence of each element from 1 to n. Now after marking it, from I am now iterating from left side. So whenever I find CNT of j equal to 0, so I can use this to decrement an element. So I will make sum plus increment this value of sum at positions where CNT of j equal to 0. Again, here is also 0, here is also 0. Now I have come to a position where it was reserved to mark an index. So here whatever value I have currently for sum, so that value sum should be greater than equal to nums of 2, because I can only use 3 elements. I can only decrement an element at most by 3. Now if the nums is greater than 3, after the decrementation the nums will still remain positive, and there are no other occurrences of 2 on the right side to mark. So this is the only position we can mark 2, but nums cannot be here. Nums of 2 cannot be 0 here. So this condition, we cannot satisfy such condition for k over here. And if sum was greater than equal to nums of 2, we just decrease sum by nums of 2, because we have used that much decrements, and then move ahead again. So again found 0, increment sum, again found 0, increment sum, again found 1, then check that condition. So here in this code you can see if CNT of j equal to 0, increment sum, and if not, if sum equal greater than equal to a of p of j minus 1, a is of 0 best indexing, but b is given in 1 best indexing, so we have to take care of that. And if it is greater, just subtract a of b of j minus 1 from it. And if it is not greater or equal, we can just make found equal to false and break. Now if we found the found was always true, no condition was there was no condition break here, and d was equal to n, basically all the elements has at least one occurrence, so they can be marked. So I will just return I plus 1, and else I will just, if I don't return anything in this for loop, I will just return minus 1, because there was no answer found for whole 1 to m. So this was third question. This was easier question. We just have to find an optimal strategy to check uh, for each k. Now we can also do this using binary search, but the constraints are low, so we can just use two for loops itself. So that's it from my side. Thank you for watching.